This video is a capacity building output from the European project Forest for EU. This innovation is on the topic of forest adaptation and climate change. The cork oak forest has been losing vitality in recent decades, with mortality and reduced cork production. The GeoSuber, Monitoring the Cork Oak Forest project, simplifies the identification of dry trees and seeks to respond to other challenges in the management and revitalization of the cork oak forest. The GeoSuber, Monitoring Cork Oak Forests project, focuses on cork oak forests, which are one of the most representative artificial systems of extensive silvopastoral exploitation in southern Portugal. Portugal's Montados are mainly made up of cork oak, Quercus suber, and holm oak, Q. Rotundifolia, although other oaks such as black oak, Q. Pyrenaica, and shingle oak, Q. Faginia, may also be present. These stands have specific characteristics, namely a low density of trees, which makes it possible to combine forestry with agricultural, livestock, or hunting activities. In total, the Montados occupy around 34% of the national forest area and represent 23% of the national Natura 2000 area. Despite its recognized economic, social, and environmental importance, cork oak forests have suffered a decline in recent decades. Environmental issues and management practices seem to be related to changes in the vitality of the trees. In addition to the issues of grazing intensity and vegetation control methods, soil tillage, for example, lack of water is an additional factor in the decline, exacerbated by the effects of climate change. Is it possible to identify dead trees more quickly? And when is the best time to strip? The Mediterranean Forest Union, UNAC, believes so and has set up the GeoSuber operational group for this purpose. With the collaboration of the ICNF Institute for Nature Conservation and Forests FCUL, Faculty of Sciences of the University of Lisbon, ISA, Higher Institute of Agronomy, Cistera, and Forestry Associations and Producers, it developed GeoSuber, Monitoring the Cork Oak Forest, a project that sought to produce maps of dead trees or trees losing vitality using satellite and drone images to help forest managers and owners. The challenge was also to provide a user-friendly interface so that the mapping could be widely used by cork oak forest owners and managers, namely through a web platform accessible on mobile devices. The project began in 2018, and monitoring work will continue in 2022 with the aim of obtaining additional information on the period of leaf change in cork oaks and making it compatible with the best time for stripping. The loss of vitality in the cork oak forest brings with it social, economic, and environmental problems, as well as a series of legal and bureaucratic procedures that hinder the valorization of these agroforestry systems. On the one hand, it takes at least 40 years for cork oaks to start producing mature cork, more suitable for the production of natural cork stoppers, so the reduction in the quantity and quality of the cork produced has an impact. On the other hand, tree mortality requires a series of procedures laid down in the legislation. Dead cork oaks and holm oaks must be physically marked with a belt of white paint. Authorization must be sought to cut them down. A visit must be made to the property to confirm that the trees are dry, and only after authorization has been issued can they be cut down. This whole process, from identifying and manually marking the trees to felling them, involves time and equally penalizing costs. The possibility of automatically classifying the vitality of trees, identifying and mapping dry trees, makes it possible to speed up the work required for felling authorizations. With this in mind, the GeoSuber Monitoring the Cork Oak Forest project was dedicated to creating mapping that would make it possible to automatically distinguish living trees from dry ones, as well as those showing a loss of vitality. The work used satellite images, Sentinel-2 and Pleiades, and the application of algorithms developed as part of the project. It also used one of the most widely applied vegetation indices, NDVI Normalized Difference Vegetation Index, to assess vegetation growth, the quantity and density of leaves and tree mortality. This index detects the amount of chlorophyll produced by quantifying the reflected radiation, and a parallel can be drawn with the quantity and vitality of the leaves. The cork oak renews its canopy in early spring despite being an evergreen species. As the historical data of felled trees accumulates, this information will allow an evolutionary analysis of the cork oak forests, which can and should be used to decide on the need to implement adaptive responses to try to halt and reverse the decline of the cork oak forest. The identification of dead cork oaks within the scope of GeoSuber monitoring the cork oak forest has been carried out by UNACS-affiliated organizations and is available to owners at their request and confidentially on a digital platform where the mapping can be used to accompany the felling request and where the history of mortality and loss of vitality is stored and easily accessible to the owner. The project was developed in 3 stages. A. Identifying areas of loss of vitality in order to establish management recommendations at the property level so as to try to reverse the trend by acting preventively. 4 reference plots were established for monitoring over the 4 years of the project, in which forest inventory, phytosanitary inventory, leaf area measurements, drone surveys, and determination of vegetation indices based on satellite images were carried out. Several alternative methods of near and far remote sensing were tested: drone, free Sentinel-2 satellite images, and high-resolution Pleiades satellite images. B. Annual inventory of dead trees and production of cartography to support the application to cut down cork oaks using a web platform to host and make available the processed information. The web application was developed based on the functional and non-functional requirements considered essential for the application and integrating the algorithms provided by FSQL. Optimizing the user interface makes it easier to visualize the results obtained from processing satellite images. This platform allows the direct georeferencing of information, or its integration export via shapefile format, namely property boundaries and management parcels, among other data of interest to the user. Each owner only has access to their information, and data confidentiality is guaranteed for the different user profiles. The figures below show the results of monitoring the vitality of cork oaks in 3 classes: in good condition, green tar, with loss of vitality, yellow, and dry cork oak, red, figures 4A and 4B. C. Monitoring the evolution of the cork oak leaf index and its relationship with the start of the stripping period. GeoSuber has enabled the development of a prototype for mapping dry cork oaks or cork oaks with loss of vitality on a property scale based on vegetation indices. The algorithm applied classifies dry trees in a conservative manner. Local verification of the results is always necessary through spot sampling, but the cartography resulting from GeoSuber monitoring the cork oak forest also makes it possible to identify areas with loss of vitality on farms. The different remote sensing image acquisition methods tested have different levels of precision, so the method must be chosen according to the objective, the information available, the scale of the work, and the characteristics of the cork oak forest. Satellite images with better resolution cost more per hectare, but they pay off in the end for larger properties or those that are part of forestry producer organizations. By sharing costs between owners who are members of these organizations, it is possible to obtain better quality images and reduce operating costs by 80%, since remote monitoring means you don't have to go all over the property to locate dry trees. The information obtained requires prior georeferencing of all the cork oaks, to be carried out only once in a 10-year period, after which the quality of the information generated must be assessed by technicians who are properly trained in applying the algorithm and analyzing the results. The system has been implemented since January 2022 in UNACS member producer organizations, which have technicians trained to apply the algorithm. All the information produced in the future will make it possible to improve the algorithm and the accuracy of the mapping generated. Current legislation maintains the obligation to physically mark cork oaks and dry home oaks, a procedure that is also expected to be updated taking into account the results of the GeoSuber operational group. Hope you enjoyed this short capacity building video, and shortly we will expand this capacitation by having a journey through the GeoSuber platform as a potential user. Stay in touch!